Hello guys, and welcome back to class. Today we have a question on the board. Now we are asked to find the derivative of this, find dy by dx. Find dy dx of this. Now if it were just two functions, I would have done product rule. But this case, it is more than just two functions. I have 1, 2, 3, and this third one is function of a function. So you see, the same thing will still apply. You leave one constant, differentiate the other, but it's going to take time and confusion. So one of the simple rule I want to show you now is the logarithmic rule of differentiation. How to use the logarithmic rule to differentiate. We are going to take the logarithm of both sides, most especially ln. Take the ln of both sides. So I'm going to have ln y is equal to ln into x squared exponential 3x into x squared minus 1 all squared. All squared. So remember, if I'm taking the ln of all this, I'm going to have something like this. Ln is equal to ln x squared plus ln exponential 3x plus ln of x squared minus 1 to power 2. So you see now, I've put this in this form. It has become plus and plus. So I can do my normal differentiation, taking one term after the other. Look at this. Ln to exponential is going to give me 1. So I will just break that down. I will have something like this. Ln y is equal to ln x to power 2 plus 3x plus ln x squared minus 1 all squared. So this is the same thing as this, because when you have ln exponential, you get it is going to give you 1. It's going to give you 1. So it's the same thing. So coming to this point now, I'm going to differentiate each of the terms. And so if I'm differentiating each of the term now, if I'm differentiating a term with ln or logarithm term, if I have something like this, if I have ln f, if I want to differentiate this, first of all, I'll pick this number and I'll put 1 over f times, then I'll differentiate the f. You see that? So this is for ln. Whenever you are doing the differentiation of ln, this is exactly what you are going to have. You would first of all differentiate. You put 1 over the value of the f there. Now for this one, f is y. This one, f is x squared, like that, because this one does not have ln, so differentiate it normal. Then this one also. So I'm going to have 1 over y, then dy dx. So I'm differentiating y now, dy dx is going to be 1 over x squared times, if I differentiate x squared, it's going to give me 2x plus, I'll differentiate this normally, I'm going to have just 3 because it doesn't have ln with it, plus this one now is going to be 1 over x squared minus 1 all squared times, so I'll now differentiate this. Differentiating this, I should have something like this. I'm going to have 2 into x squared minus 1 multiplied by 2x. You see that? I will have all this. So if I continue like this, I have 1 and this. I have 1 over y dy dx is equal to 1 of the x here will cancel 1 of the x here. So I will have 2 over x, right? Then this is just 3 plus 3 plus, if I multiply this, 2 times this gives me 4x. So I have 4x into x squared minus 1 all to power x squared minus 1 all squared. Okay, so the next thing now is I'll just take my y to multiply everything here. So the left hand side I have dy dx. So from my left hand side now I have dy by dx is going to be, I'll use this one over y here, I'll cross multiply it here. So I have y multiplied by 2 over x plus 3 plus this and this will cancel out, so it's remaining 1 here. So I have 4x all over x squared minus 1. Okay, now my y, the value for my y is this. Look at my y, look at the value for the y. So I'm going to impute this value for y into this place. So I'm going to have finally dy dx now is going to give me x squared exponential 3x into x squared minus 1 all squared into 2 over x plus 3 plus 4x over x squared minus 1 equal to this. So this is the solution.